All right. Okay, so this is all the materials that I prepared for this course. All the PowerPoint slides are there. The little C file we'll be going through is on there, and a little primer for GDB is also on there. So let's get out of that. Okay, so a little brief introduction. My name is Michael Basha. I'm the Vice President of LUG. This is my final year at UIC. I have a big interest in security, specifically security research, so looking into vulnerabilities. And this year I'm hosting a brand new special interest group. This is through the ACM, but I just got confirmation that my meetings will be on Tuesdays from starting at 5 p.m. probably for about an hour or so each week. You don't need any background to attend them, although some of the meetings might go a little over your head if you don't have any background, especially with the lower level stuff. But there will be plenty of material that you'll find accessible and you'll be able to follow along just fine. So the first thing I want to say is to follow this presentation today, you don't necessarily need Linux. Windows 10 with its most recent anniversary update added Linux subsystem, so you can get most of the functionality of Linux within Windows 10. I'm actually using it for this presentation because I don't have a screen capture for Linux that works really well. So what is Git? Git is a free and open source distributed version control system. So basically what it is if you're working on a project, it allows you to easily save and make checkpoints and collaborate on it. So the first thing I want to say is Git is not the same thing as GitHub. Git is the actual program that you're using. GitHub is basically a host, so it hosts repositories for you. It's proprietary. Git is open source. GitHub, its backend isn't open source, and so on and so on. So the first thing I want to talk about is how Git actually works. Can you guys see my mouse on there? No? Oh wait, yeah, you can. Okay. So basically, when you're working on a project, you'll have a bunch of source files. Here I just have some C files and header files. That doesn't really matter. Git treats all files the same. Thanks, Chase. So when you're working with Git, the first thing that you do is, well, you make your source files, and then you add them to what's called the staging area. So in the staging area, the source files and anything that you add to it hasn't been officially committed yet. It's just saying that I'm ready to upload these, basically. And in quotes at the bottom, I have git add and git commit. Those are like the associated commands. So once you put them in the staging area, when you do a commit, it'll actually push those changes to the repository. So this is what a typical workflow looks like. This one is only one branch. So in Git, you can have, for a single repository, you can have multiple branches, and I'll talk about what that means in a little bit. So the master branch, as it's typically called, is the main branch. So this is where, if you were to look up, so the Linux kernel is also available on GDB. If you look at the master branch, it'll be the most recent stable version of the kernel that's out there. So each of these bubbles represents a commit. So this, the init would be the initial commit when it's like empty. So with each commit, generally, you want to do one specific change that won't break anything else if you push that to master. So here, this commit just added a single function, function1. This commit added another function, function2. So with Git, you can branch off of another branch. So when you branch off, you're basically making a clone of the repository, except this is like a separate from master. So if you wanted to implement, let's say, a test function without breaking what's in the main repository, you'd make a branch first. So in this example, there's a little, the red is the test branch. So we're branching off from main. So we're getting our basically another copy of main at this point. So this test branch has the init function 1 and function 2 in it already. And then within your test branch, you can mess around, add more commits. So here I have another test function that I committed to the local repository. So once you've made your tests and everything works fine, or it looks like it works fine, you can push these commits back to master. So typically what you'll want to do is on your master branch, you'll only be wanting to, you'll only be wanting to pull change. So you never want to, this is like a bad example. You generally don't want to push directly to master, but so this test branch, once it makes the final commit, it can push to master. So now master also has test function. So it's like caught up to speed. So there are a couple difficulties that you have to be aware of. So let's say, so test branched off at the same position as before. It branched off at added function 2, right? But let's say, typically you have multiple collaborators on a project, right? So let's say someone else made a function and added that to your project. So that's what this other commit is. If test branch were to push its changes to master right now, it doesn't have function 3 in its local repository, right? Because it branched off before that. So this doesn't exist in the world of test branch. So what Git forces you to do is you need to first fetch those changes and merge them into your local branch. So that's what this little dotted line is. So first you need to get function 3 and then merge it with your local branch, so that when you do push to master, all the changes are still okay, like nothing will be missing. And if this is confusing, don't worry too much about it. Typically for the schoolwork you'll do here, we won't be doing anything this complicated. So first things first, Git requires you to supply email and name with your commits, so Git knows where these commits came from, and so other people know as well. So you can do that with git config, and then the -- global just says for all your future repositories, I want you to associate this name and this email address with it. So if you guys run these commands real quick in Git when you first start it up, you'll never have to touch it again. And again, all these slides and everything are on the repository that I showed you at the beginning. So if you downloaded that, then you have all this. You don't got to worry about like doing this right now. So I'm going to go over a couple of the basic commands that are in Git. So git init basically initializes an empty repository. Git status shows you what's currently in the staging area, so the area that you place files in right before the commit. Git log will show you the commit history. So, well, I'll show you an example of this later, but it'll show you all the commits that have been made to the branch that you're currently working out of. Git add is used to add files to the staging area. You can use star as a wildcard, so star will add everything to the staging area. And there's a special file called the git ignore file. I won't be talking about it today, but if you have a git ignore file, you can specify what types of files that you would like to ignore when you're adding stuff to the staging area and eventually committing it. Because generally, like if you're working in C, right, you don't want to commit all the intermediate .o files or the binaries themselves. Generally, you only want to commit the source files. Git commit will actually commit what's in the staging area, so you can think of that as like pushing to the repository. And git reset will reset to a prior commit. So you would use git reset with git log typically. So you can use git log to get a list of the commits, and let's say you push something to the repository and you realize it was a mistake, it broke a bunch of stuff. You can do a reset to that a prior commit to basically reset where you were. So these commands are specific to remote repositories. So git clone will copy a repository. So you give it like a URL, and it'll copy that remote repository onto your local machine. Git fetch grabs new remote branches and tags without merging. So in that prior example I did back here, if you did a git fetch first, it would just tell you that, oh, there's a new function 3 in the master branch that you don't have locally. So that's what that does. Git merge will actually take the changes from the remote repository and add them to your local repository. Git pull just does fetch and merge together, so that's typically what you'll use. Generally, you want to be careful and fetch to see what changes are there first, because if you do a git pull, it'll do the merge for you, so should be a little bit careful when using that. And git push will push any commits that you've made to the remote repository. Okay, so I'm going to do a little demo. Okay, so I'm going to, so I'm in my documents folder right now. ls just lists the files in the current directory. So right now I don't have my Git repository on here, so I'm going to get this URL. So when you guys, if you guys want to do this from the command line as well, you should, unless you've set up an RSA key or ahead of time, you're going to want to use HTTPS. So basically GitHub wants you to authenticate before you download these files. I already set up an RSA key ahead of time, so I don't have to keep entering my password every single time. But so I can clone my repository with git clone and then the URL they supplied. Right, so it just downloaded the entire repository to my local machine. So now you see I have a GDB and Git presentation folder. So if I change directory into it, there are all the files, the resource files that I had from there. Okay, so inside the actual repository, I can do a git status. So it's telling me I'm up to date with the master repository right now, and nothing's in my staging area. If I do a git log, it'll show you a list of all the commits that I've made. So it shows them in, it shows the newer commits first. So this was the most recent one. And what was it? Yeah, I had a couple more other commits. The git log is actually a little bit more complicated. You can, there are additional parameters you can pass it to look like for a specific commit message or between a range of dates or whatever. I won't be going into those right now. Okay, so I'm going to change a file in one of these and commit it to my repository. Let's see, let's go into adder.c. Right, so here's the test file that we'll be using later. I'm just gonna delete this line real quick and then save it. Right, so if we look at adder.c again, that comment's no longer there, right? So I'm gonna add that file to the staging area to get ready to push it to the remote repository. So that was adder.c, right? So if I do a git status, it'll say under changes to be committed, adder.c, because it's now in the staging area. So if I do a git commit, so when you run git commit just by itself, it'll commit the changes you have, and it'll open up your default text editor to write a commit message to it. If you use the flag M, you can write the message on the command line itself. So I'm going to do that here. So let's say removed comment from adder.c. So I made the commit. So if you look at the most recent one, removed comment from adder.c. So our commit was successful, but it's still on the local repository. So if I want those to be reflected on the my repository on GitHub, I have to push my changes. So git push origin master. So origin, when you clone a repository, it automatically sets that repository's URL to origin. So you can refer to that base repository as origin, and master is just what branch I'm putting it up to. So I'm writing those changes now. So if you go back to my repository on GitHub, you can see that the change is there now. If you go into it and look at it, you'll see that comment's missing, right? Okay, so now let's see what happens if you have a merge conflict. So I'm going to go back to my desktop. So cd desktop. There you go. So I have a local repository that I cloned it earlier before I made these changes. So if I go to git log, you'll see the most recent commit was yeah, this one. So it wasn't the one where I deleted the comment. So if I were to if I were to edit adder.c here, let's say I added, I don't know, this is a comment at the bottom, right? And I add it, or git add adder.c, git commit, added a comment to adder.c. It'll still let me commit that because this is all local. But if I try pushing, it should say that there's a conflict. Yeah, so don't be scared. It's just saying that the remote branch is ahead of me. So I need to first get those changes and merge them into my own before I can commit what I have. So let's do, I'm just gonna do a git pull. So I didn't change much. Git's smart enough to detect most changes and do them automatically for you. So if I do git pull origin master, yeah, see. Oh wait, okay, so it wasn't smart enough this time. Let me look at adder.c. So when there's a merge conflict, Git will make you manually go into the files and choose which changes you want to keep and which ones you want to discard. So let's just discard all of these. So git add adder.c, git commit, fixed adder.c. So git push origin master. So yeah, so I merged those remote changes into my current working branch, and after I did that, now I'm at an equal spot with the remote repository, so it'll let me push my changes that I had originally onto the remote repository. So in case you guys were a little bit lost through all of that, I am recording this. I'll after today, I'll update the repository with a link to the video. I'm gonna just upload it to YouTube. So if you want to go back to a specific part or see like what the actual commands I typed in were, it'll all be up there. So that was that. So I'm gonna move away from Git now and talk about GDB. So GDB is the GNU project debugger. The GNU project is basically an open source project that contributes a lot of the tools that you see in most Linux distributions today. It's a multi-platform debugger for C, C++, Objective-C, and some others. It does use a command line interface, so that might be a little bit scary, but hopefully after today you'll be a little bit more comfortable going through it. And there are a lot of other debuggers that act just as a front end to GDB. Xcode uses GDB in its background, and Eclipse and NetBeans and some others can actually interface with GDB if you want to use it as a debugger. So the one thing, if you guys take away anything from this, is the one command you should learn is help. So if you type in help in GDB, it'll give you like a list of commands that you can get more information on. And read the manual. There's a lot of information out there. You just have to look for it. So this is what the interface looks like. This is actually off of Bash on Ubuntu on Windows, the Windows 10 update thing that I mentioned earlier. Yeah, I'll get to that later. Oh, so how many of you guys are in 141 right now? A couple? Is anyone in 111? Yeah. What are you guys using in 111 right now? Or what programming language, sorry? Oh, okay, so Python. So this might be a little bit confusing, I'm sorry. But when you're in 141 later, it'll make sense. So I think you guys are using C in 141, right? C? Yeah. 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 So when you're compiling in C, you're going to want to, when you're compiling your source files with GCC, you're going to want to compile it with the flag G in order to give you the debugging symbols. So it'll, when you're actually debugging with GDB, everything will make more sense. So I'm going to run through the basic commands, again, just like Git, and then we'll do a quick demo at the end. What's up?
So how do you pull out the program? How do you pull it up?
Oh, okay, yeah, sure. You can just type GDB and it'll bring up the debugger. Yeah, if it's installed. If you're running on Windows, you're gonna have to either get the Linux subsystem that comes with Windows 10, or you can get something like what is it? Yeah, you can use a VM, MinGW, Cygwin. There's a couple options that you can use to get it. Yeah. Okay, so let's go back. So, yeah, so when you're starting a program with GDB, if you, wait, did I leave it here? Yeah. So you type GDB to start GDB, but if you want to load a binary file into GDB, you can run GDB with that file name as a parameter, and it'll load it for you. So the first command, run, basically runs the program for you. You can also supply optional parameters to pass into the program that you're running. So if you're not familiar with this notation that I have here, brackets mean that that parameter is optional. So you can have it or leave it out, it doesn't matter. Let's see, break. So break sets a breakpoint at the specified location, in the program. So there are a couple of ways to set a breakpoint. You can refer to a function by name. That's typically how you'll use it. You can also break at a source code line. So if you say break and then the line number, it'll actually break at that line number. And yeah, there's a lot more than break can actually do. If you type help break, you'll get the whole list of it. So clear will clear out any breakpoints that are at a given location. So if you break at main, you can, and you don't want to stop there every time, you can clear it with clear. Continue resumes the program execution after you stop at a breakpoint. Step will try and step through a single line from the source code. So one thing to note is that step will actually go into any embedded functions that are in the source code line. So I have a little example there. So if you're calling foo, but foo takes as an, what was it? So if you're getting the return value from bar as a parameter for foo, and you try stepping over that line, it'll step into bar first. I know it's a little confusing. You don't have to worry too much about it. Next is similar to step, but it won't actually step into those embedded functions. List will list source code lines in the display so you can see where you are in the code. Disassemble does the same thing, except instead of displaying source code, it'll list out assembly instructions. You guys don't have to really worry about that right now, unless, is anyone in 261? Okay, so yeah, you guys are gonna want to use that. Info, so info actually has a bunch of subcommands available to it. The only one I know off the top of my head is info registers. So if you type in info registers, it'll give you all the values of the registers. And P, or print, prints out the value of an expression. So you can print out the value of a register, you can print out the value of variables and such. X is short for examine. So examine will let you look at the actual values in memory of whatever you specify. There are a couple examples I have in the little primer. I can do I didn't have anything planned in my little demo, but I could go over that if you guys want me to. Set, so you can actually manipulate memory with set. So you'll actually go out to memory and you can change the individual bytes or entire buffers if you want to. And the actual formatting for it can get kind of messy. I've provided some examples in the primer text that I have in the repo, so you can reference these back later. And then layouts. So GDB in its base form is just the single command line interface, which doesn't help you too much. So there are various layouts that offer graphical displays to help you in your debugging. So there's ASM, which is assembly, regs for registers, and SRC for source. So in this little screen cap I have right here, I have the registers showing and the individual assembly instructions showing as well. And you can change your focus between the different windows using focus. So you can change your focus to the assembly window, so you can scroll through the assembly instructions one by one if you want to. Focus command to go back to the actual command line, so on. So I'm going to do a little demo. Let's get that out of here. Let's see. Okay, so I didn't compile it yet, so I'm going to compile it real quick. So remember, if you plan on running something in GDB, give GCC the flag G symbol, so it'll generate the debugging symbols for you. So basically what that means is that all the variables will have their names when you're running the GDB, because the compiler typically optimizes those out because you don't need them anymore. So adder, let's see. So can everyone see that okay? Yeah? I'm gonna make it a little bit bigger. So GDB adder. So here's the basic interface. So I'm going to just do a run through. Oh wait, I guess I didn't show you guys the source code. So this is what adder.c looks like real quick. So basically what I'm doing is there's this little check right here to see if the number of arguments is correct. So I want 2 numbers, and there'll be some statements that we're going to mess around with here. So this is just setting a variable to 25 and printing out 5 times 5 is the value of that variable. The second print statement is actually printing out the value of the 2 arguments that you pass in on the command line. And this last print statement is printing out whatever's located inside this buffer. What's up, Nigel?
What's this ID?
Sublime. Yeah, so we don't actually have there's a presentation on, when was it? I believe it's wait, do you remember when Matt was going? Monday. So if you guys want to learn more about Vim, so that was the other editor I used earlier. Vim. So if you're on a Linux machine, well, most Linux distros have this installed by default. So this is one text editor that you can use. I use this if I'm only writing like really short programs or whatever. Most of the time I use Sublime because it looks a lot nicer. But everything you can do in Sublime, you can do in Vim too. Vim's pretty powerful. Yeah, so this last print statement just prints out whatever is located in buffer, which is fog, the word fog. So let's do this. So remember, you had to have 2 arguments. If you pass just one, it'll yell at you. These warnings are because of the Linux subsystem on Windows 10 isn't like bug-free yet. But this is the actual output here. So please enter 2 numbers. So if I do run 5 and 10, we have that first print statement, which was 5 times 5 is 25. And then this was the actual result from adding these 2 parameters together, 15. And then the last one just printed out what was in that buffer, right? So let's dive a little deeper into this. So we're going to set a breakpoint at main. So what this is going to do is when we run the program again, here, I'll just do that right now. So run 5, 10. So it'll stop execution right when main starts. So if we do list will print out 10 lines of source code focused around where you currently are. So we're somewhere right here right now, right? And it prints 5 on both sides. If we wanted to look at the disassembly, we could look at that. It's scary. And there's a little arrow to tell you which instruction you're currently on. So I'm gonna show you guys print. So if you remember back here, yeah. So back here we had a couple of variables. So we have this global variable called buffer, a local variable called var, and then we have the command line arguments that we passed in when we ran it. What's up? This? The command's called disassemble, but you can just type disass to get it. Let's see. Oops, I should have muted that. Okay, so yeah, we have those variables. So print will be able to locate those variables for you. So type out what's located there. So if you type print buffer, it'll actually return the address of buffer in memory. So buffer is located at 400734 in hex. And if you actually go into that memory and examine the memory there, you'll see the word fog there. So we can look at that in a little bit. We can also print out the value of those command line arguments. So print argv1. So argv1 is located at this address and it has a value stored there of 5. So if you remember, I ran it with run 5 and 10, right? So if we do the same thing with argv2, we should see 10. You see it. So I'm gonna change the layout now because this is kind of clunky. So layout source. So now we have a list of our source code, and I don't know why it did that. Layout regs. Okay, this is not working. One sec. Layout. One sec. I think it's because I changed the window size midway, and GDB doesn't like that for some reason. Oh. Break main. Run 510. Layout. There you go. So I have the source code window in the middle, and on top are all the registers available. I'm this is a 64-bit binary, so you have a lot more registers than you would in 32-bit. If you don't know what that means, don't worry about it. This is mainly for the 261 students. Okay, we're gonna advance up into the print. So to advance in the code, you can either use next to jump over source code lines or step to actually step into functions. So we're gonna use next. So after this line is executed, it'll set the variable var to 25. So if we run this line, also, if you're in GDB, you can keep hitting enter to rerun the same command over and over. So if you're just stepping through the assembly instructions one by one, you can just keep hitting enter instead of typing next over and over and over again. So if we look at var now, we can see that var has been set to 25. Let's see. So what I want to do now is demonstrate how to use set. So the program set the value of var to 25, but I want to change that. Let's say I want to see what happens if I set it to 100, right? So this is going to be one of the ugly looking ones. So I'll explain it as I go along. So we're saying what we're about to, the memory that we're about to address, we want to treat it as an integer. So it'll go to that memory address and look at the next 4 bytes. Or I guess 8 bytes in 64-bit. Where am I? Yeah. So, and then the address of that variable. So if you're not, so I'm gonna use focus command to change the focus back to the command window so I can like scroll through my previous commands. So set int var. So if you're not familiar with C syntax, the ampersand just says, I want the address of where the variable var is. So we're gonna go to the address where var is, treat it as an integer, and then set it to 100. Oops, not like that at all. So 100. Oops. Okay, so now we've set the value of var to 100. So if we do a print var, we see that it's 100 now, right? So if we do next, this print statement is saying, printing out 5 times 5 is, and then the value of var. So originally it was 25, but I should really mute that. Settings. Okay. So if we go over this print statement, it should say, okay. So one thing about the layouts is that they can be a little wonky sometimes. If it ever screws up, you can use Control-L to refresh the screen, but you can't really see the printout. It's right here. It's like in the little mess. So 5 times 5 is 100. So I'm gonna just, you can refresh the screen using Control-L, or if something goes horribly wrong with the layouts, you can use Control-X and then press A afterwards to leave the layouts. So layout, source, layout regs. All right. Okay, so we successfully modified the value of var in memory, right? So I'm going to go to next. Oh wait, no, I'm not. Okay, so there was one more thing I wanted to do. So remember, buffer was set to fog, right? We can actually go into the memory where the buffer is and change individual values in there. So the buffer is located at this memory address right here, right? So we, buffer was a character array, remember? So each element of that array has 1 character in it. So if we go to, let's see, if we go to that memory address, so 0x40734, and we set it to D. So this address was the start of the buffer, right? So if we change that to D, and then we print out what buffer is now, it'll say dog. So if we run the next instruction, oh wait, here it is. Yeah, there you go. Oh my god. Here, I'm gonna run through this again real quick and without the layouts. Oops, quit. So GDB, adder, break, main, list, step. Oops. So run 5, 10, step, step. So I can change the buffer right now without modifying the program flow. So let's see. Oh wait, let's do buffer. So buffer still hasn't been modified, so we can set as treat this address as a character. Oops. 0x4. And then we want to set that to D. Oops, what did I type wrong? Wait, what? Oh, yeah. There you go. Okay, so if we print buffer again, yeah, it's dog. So if we step through this, oh no, I didn't mean to step. I wanted to do next. There you go. Okay, yeah. So this next line will actually print what's in that buffer, and it prints out dog, which is what we wanted it to do. And then if you type continue, you can continue program execution after hitting that breakpoint and stepping. So if we hit continue, it'll exit as normal, like normal. Okay. So that was my entire presentation. Do any of you guys have questions? And I know you guys probably have some. I can go more in depth into it if you want. Nothing. All right. Thank you guys for coming in. There is another presentation on Friday that is about what's it about, Jason? Yeah, terminals. So pimping out your terminal. Monday we have a presentation on Vim, like I mentioned earlier, and Tuesday is going to talk about different graphical environments for Linux, so Cinnamon, GNOME, LXD, those types of things. So thank you all for coming again, and I hope to see you guys at some of the other ones. All right. Do you guys have questions? Did you want to yeah.
Well, right now, my thing is running at LL.
I don't exactly know what that means.
Yeah, I was trying to install LUG Newbie on here, but then it requires me to install this code sign thing. So presenting a certify GDB is.
So I don't know how to solve that specific problem, but as a CS student, you have access to Bert and Ernie, which are the CS servers, which do have GDB on there. So you can SSH to them. Do you know how to do that? Yeah, it is. Yeah, I mean, it's not too bad. I think basically my entire first year, I didn't have a computer or a laptop to work off of, so I worked off of my Kindle. I SSH'd into Bert and did all my work on my Kindle. So it could be worse. It's not too bad. It's doable. Yeah. Did you guys want to, wait, have you guys started the bomb lab? I don't think so. Right? Oh, he assigned it yesterday. Yeah, so so I would definitely, at the very least, memorize that one, layout at ASM, because it helps you so much. Being able to see all the assembly at once, so you know exactly where you are. And for the assembly, I would use NI, so next instruction, so it'll complete each one of these one by one. So oh yeah, so when I mentioned earlier that you can use break to break off at a specific function call if you want. In the bomb lab, there's a function called like bomb explode or something. Like if you do an object dump on the binary they give you, you can see a list of all the function names, and one of them is bomb explode or something like that. So the first thing I would do is like break bomb explode, right? Because you want to stop right before the thing executes. So if you ever get there, like you won't blow up. There's actually a couple more things that GDB can do that are pretty cool. So let's get out of here. So let's say you had a list of functions that you wanted to run every time when you started GDB. So let's do vim test that, well, orders.text. So let's say when you start GDB, you always want to make a breakpoint at main. You always run a step 5 times, and so on, right? So you can have a list of GDB commands in a text file. Then you can do GDB adder. You load up the binary, and I believe the command source, and then your text file, so orders.text. So it'll actually take the commands from that text file and run them for you. Oh yeah, so I'm not actually running, so I can't step. So I messed up my orders, but so you could do like break at bomb explode, break at challenge 1 or whatever they're called. You can put a break at each one, and then once you solve the phase of that bomb, you can have like the password or whatever you have to enter in listed in that text file, so you don't have to worry about accidentally mistyping something and having your bomb explode. So like once you solve it, you'll be able to write it into a file and just source it and then get back to where you left off. What else did I want to talk about? So let's, oops. So I did break main, right? Yeah. Yeah, see, so it already set that previous breakpoint there from the orders I gave it. So if I do run 510, so layout ASM, layout regs. How far deeply did he talk about assembly? Oh. Yeah, so there's actually a bunch of different types of assembly. The one you guys are working with is x64, so x86 464-bit system. So there's also, if you try looking up guides online, there's also a bunch of different syntaxes available. So like the one that GDB uses is AT&T syntax, but there's also Intel syntax available. And it's kind of annoying because the individual instructions are like, they're called the same thing, but like the operands are like switched around. So in AT&T, it's always source then destination. So if you had like an add RAX to RBX, right? It'll take, focus command. Yeah, you'll also want to do that. If you want to like cycle through your commands, always change the focus back to the command window. So let's say we had add L RAX to RBX. It takes RAX and adds it to RBX and places the value of that into RBX. So it's source and then destination, right? The destination is where the final value is going. In Intel, they switch it around for some reason. Yeah, and then in Intel, you don't need to refer to the registers with parentheses, or with the percent symbol. I don't know what it's actually called. Yeah. So, yeah, but it runs, yeah, AT&T. If you want to, you can specify it to run in Intel if you really want to. I mean, it's your choice. A lot of the guides out there do use the Intel syntax too, but if you have an interest in the lower level workings, like, so like I'm interested in like security research, like actually finding vulnerabilities in programs. And most of the time in that, you only have access to the binary. They're not going to give you the source code to look at to find like problems with it, right? So when you have the binary, all you have access to is the disassembly. So if you want to do something like that, I think it's really cool. You need to like get really comfortable with assembly and like what's going on at a lower level. But if you want to do something like software dev, this doesn't really matter as much because you're never going to be going this slow. Yeah. Well, if you guys just started it, I don't know how much I could tell you about it. If you guys have specific questions like later, you guys know about the tutors, right? And I'm like always in the CS lounge. I had a project that was due yesterday in my security class. I could show you that real quick. So let's exit out of here. CD. So the class I'm taking right now is called Software Vulnerability Analysis. Basically what we're doing the entire time is writing exploits. So my assignment was to write a big number class in straight assembly. So this is all hand-generated assembly. Me and my partner actually had to write all of this out. It gets kind of long. Luckily for us, it was a 32-bit, so it's not as complicated. But yeah, it's still a lot. Yeah. It's a nightmare, let me tell you. I can totally understand why they invented higher level programs after this. I can't imagine like trying to write a compiler for C using only assembly. It's a nightmare. Because it's like, the way I think of it, it's like coding in C with short-term memory loss and Alzheimer's. Because you can only ever remember 4 things at once at the same time. So if you want to remember something else, you need to save something or one of your registers in memory, then pull it back off of this. It's a nightmare. It's really hard to keep track of. But like I said, if you want to like actually get into it, like writing your own custom exploits for like stuff you find, like a lot of the stuff on the Android platforms is written in ARM, and that's first written in C and then compiled to ARM. So it has access to a lot of like standard C libraries, and a lot of the apps out there on the App Store aren't very secure. Like you can find vulnerabilities really easily because people just aren't aware of like what's unsafe.
Why is it Vim so sick? Like, is it like
Vim?
title on the lab?
Oh yeah. So I have an extension called Airline, which basically adds all of this nice looking stuff. The presentation on Monday that Matt will be giving doesn't include this. I've been trying to like get him to shoehorn this in because it does make Vim look really nice. By default, it doesn't have any of this. Vim looks really plain. So let me see something. I believe Airline also tells you what branch you're currently on if you're using Git. Yeah, there you go. So at the bottom it tells me I'm on the master branch too. It's actually really nice. But yeah, usually I only use Vim if I'm writing something short. If I'm writing anything bigger, I like using Sublime because I think it looks really nice. Yeah, and Sublime has a lot of cool things too. You can like, I don't know. Yeah, you can like search for something in between like all your open files, like jump to a, I don't know. Sublime's really nice. I don't want to like jump into teaching you about it.
And then it will just permanently highlight it in the code every time I run it.
Oh yeah, that's really, I know exactly what you're talking about.
It is so annoying. Like, it's just permanently highlighted. I'm like, okay, I can't really get out of it.
There's a way to turn it off. I always have to look it up because I always forget.
Yeah.
Oh yeah, here. I can let me get that for you.
That one thing from earlier where you had like display it's like DIS, right? Like,
This ass.
This yes.
Yeah.
And then what exactly does that do? Like
Oh, well, if you already have the layouts,
Thank you very much.
if you already have the layouts open, it doesn't really do anything.
Oh,
but
okay.
if you're, I don't know if I told you guys, but you can use Control L to refresh or like clear the screen.
Like all I do is just type clear and that's it. Like,
Yeah.
It's just Control L. This is the shortcut there.
Yeah. So if you type disass, it'll show you the assembly
okay.
dump for like where you are. But if you have the layout, this layout regs, that's all you need. Yeah.
And what's the kind of like object dumps? Because remember he said that was.
Oh yeah.
Because I don't know exactly what that is. Because yesterday was the first time I ever taught assembly code, and everyone was just like, "What is this?"
Yeah. So object dump basically takes a binary and gives you like the assembly. So it's dump. And I think it's flag capital S and then the binary. I think it was. Oh yeah, there you go. So it'll give you like a dump of all the assembly in that binary. And if you don't want to look at it like this, you could like pipe it out to
Like a text file.
or something. Yeah,
Okay.
I don't want to do that for you, but
Okay.
yeah. And then you can like look at it in your favorite text editor or whatever.
Because like what else would it be useful for this like bomb? Because like I said, no one really knows about it yet. So, like,
Yeah. So
he's saying, can you remember saying object dump? Because the thing is, I came here because he's talking about GDB, and I didn't hear about GDB, so I'm kind of glad I came here.
So,
the layout stuff.
the layouts, yeah. I remember when I first started the bomb lab, I had no idea about the layouts. So I was, what was it? I was always typing disass like after every single command, and it gets so annoying because like you want to know exactly where you are in the code so you don't accidentally step over something important.
Right.
But,
So basically, because I remember he's going over like breakpoints, so let's go like this. So just like you said, break main, right? Main, and then if we do layout, it said ASM, right?
for the assembly.
And then layout, right?
Regs.
So pretty much, the break is right here or something.
So wait, let's actually run it. So run 5, 10, whatever. So yeah, this is the action. So it's super sensitive.
Oh,
So
I get that a lot.
so the instruction that's highlighted hasn't actually been run yet. That's the one that's going to be run next.
Okay, and then you said hit enter to go to the next one, or?
Oh, so you can use if you're in the assembly, I would use NI. So next instruction, it'll step through each assembly instruction one by one. So one by one by one.
Okay. And the thing is, like, I remember he's kind of talking about, like, basically, so it's like we print, so basically, like, we set a breakpoint and we print out the value at the current time, something like that.
Wait, sorry, can you repeat that?
Because I'm trying to remember from yesterday's lecture, it's something like, where it's just like, we're kind of setting a breakpoint, going on line by line, and then for each line, we want to print out the value of what it currently is, or something like that.
What current?
I don't remember exactly. Like I said, he kind of skimmed over a lot.
Maybe he was talking about the registers.
I think so, yeah.
You can print a variable, right?
Yeah.
Every time
Yeah.
you step
But I
in
mean,
it,
if-
so just like print it out for you again.
Yeah, but that's not going to change with every instruction that you step through. Did he talk about like what all the different registers mean, like what RIP is?
I don't really know.
just R. You just said R64.
Okay,
That's
yeah,
it.
so
He didn't talk about anything
he's
else.
probably got a lot to talk about still.
Yeah, because yesterday he kind of just threw all this stuff at us, and no one really understood what was happening. Just threw it all.
Yeah,
at
that's
us.
how it was
That
for my
first-
class
first
too.
thing-
That was right.
Yeah.
Yeah, if I were to go back and do bomb lab again with like what I know, it would probably take me half an hour. But yeah, when you first do it, it's like really overwhelming because this is everything that they've been teaching you doesn't help you with
Exactly.
this.
Like listening to the first time talk about assembly, and no one really. Like,
Yeah,
knows
that's
this.
okay. That's normal. I was completely clueless too. Yeah,
Trying to think
but
of-
luckily, you can download as many bombs as you want. So you can have one as like your test bomb that you blow up over and over again. But like I said, if you break it, the bomb explode or whatever, you should never blow it up.
Okay. I think what else? Because I think like like right now I'm just gonna be watching that lecture again, so I can hopefully after looking at
shoot.
this.
I forgot.
You stop.
Yeah, I never stopped.
Wait, are you recording?